Hi, my name is Kshira Saagar. I work for the Iconic. My name's so complicated that I had to tell Rob 6 times and I have the other people 15 times because when I forget. My parents had fun naming me, so I put my name out there. This is how it's spelled. If you get it wrong, it's fine, even I get it wrong. I'm from the Iconic. How many of you have heard of the Iconic here? How many of you shop? Okay, so that's 60%. The other 40% are new customers now, and my target's done. Right? So the way I rationalize to myself is anytime somebody's on their phone, when I get too boring, is people actually shopping. Right? So you can be on your phone, on your laptops, and I really don't mind because I'd assume that you're shopping. Okay, there are two things to know about me. One, I talk really, really fast because there's no filter between my mind and my mouth. So I end up saying things. So you should put up with that. And the second thing is, I talk really, really fast. So if you didn't get it the first time I said I talk really, really fast. So please stop me if you feel that I'm talking really fast. I tend to get really fast. Yeah, okay, so that took a while. Okay, I work for the Iconic. The Iconic is the largest clothing and fashion retailer in Australia. I'm sure all of you have shopped there. If my talk gets boring, which it usually does, go ahead and shop, and I'll be really happy. The slide was not supposed to say anything, but that's the homepage of the slide. What I'm going to talk about is the ABCDs. Typically, when we do these talks, I give a topic, and then 6 months down the line, when I look at the topic, I'm like, what was he thinking when I gave the topic, right? So I just make it simple. It's basically ABCD, actively bettering your company with data. Or I like to even make it more BuzzFeedy, which is how to stop thinking about data and actually start using it. So what I'm going to talk about is the Iconic's journey. It's a true story. This is not a philosophy. I'm not trying to proselytize you. I'm not trying to convert you. I'm just going to talk to you about the story that the Iconic went through in terms of data and data science and analytics. And then please feel free to give me more advice and feedback once you've done. So to make sure that it's a true story, let me tell you where we were and how we started. So this is a data pinball. I have an old friend sitting right at the corner who knows this. So we used to have, this is called a data pinball, right? So you had 3 different teams, and I'm sure a lot of you have these 3 teams or 4 teams or 5 teams, depending on how many numbers you like. So you can start anywhere in this data journey, right? So you go to the data team and say, hey, I need to understand, I've done something, I need to understand how it's worked. So what the data team would tell you is, oh, this is more of a BI thing, go ask the BI team. The BI team would say, yeah, come on, ask me. And then you ask them, they're like, oh, I think these are bits of analysis, just go ask the analytics team. The analytics team will like, I'd love to help you with that, but I don't have the data for it, go ask the data team. And so you start where you are all over again, and then you go around in this pinball, and this loop never gets broken. Depends on how you break the loop and how you break the cycle. So how did we break this loop is what I'm going to talk about. So before we go there, I usually like to tell a story because this story is more interesting than my story. So I'll talk about the data action loop and what it means for the Iconic, but there's more importantly, there is something called the data information knowledge wisdom pyramid. How many of you know the DIKW pyramid? How many of you have heard of it? Okay, so thank you. Otherwise, my next 5 slides would be wasted. Okay, so the data information knowledge wisdom pyramid, right? So data is at the bottom of the pyramid. I'm not going to bore you with the philosophical basics, but what technically it means is data. We collect data all over the place. So think of me driving in a car, or think of yourself driving in a car. Think of me driving in a car. I'm going down the road, and then I see 2 different data sources. One is the signal, or the lights have turned red. And then the other one is I look at my speedometer and it's at 60 kilometers per hour. So those are 2 different data sources. I'm just collecting data. That's what a lot of companies do. There's a CRM database, there's a transactional database, there is marketing database. Everyone collects data. When does this data become useful is when you put it 2 and 2 together and you get meaning out of that data. So for example, when I say, oh, there's a signal in front of me that's turned red and my car's still traveling at 60 kilometers per hour. This is typically companies putting 2 and 2 together saying, oh, I sent out an email and there is more sales. Okay, that's an insight. That's all. People stop at data, collect data and stop getting insights from that data. But when does data and information become actually useful is when you apply knowledge to it. Knowledge is typically in my relationship with the business is the knowledge. And in this relationship, knowledge is my wife. She's sitting right next to me and saying, you're still traveling at 60 kilometers per hour. The lights have gone red. If you don't apply brakes, you're going to pay a fine. That's what the business tells the data team. You found this insight. This is how you interpret this insight. This is what happened. So how do you make that information knowledgeable is what is more important. But at the end of the day, knowledge is nothing. Like if I don't listen to my wife, I'm still going to pay a fine. It's absolutely at the end of the day taking action. How do I take action? And how do I apply the brakes and stop the car? So this data information knowledge wisdom or data information knowledge action is typical pyramid that companies go through to actually make sense of data. If somebody asks me if I had to tell my grandmother what I did for a living, I can't tell her I do a data job. I can't tell her I do data science. All I tell her is I get this thing called data and I help people make decisions. That's all the data team is supposed to do, is translate data into helping people make decisions or action. So how do we do that is what it's all about. But more often than not, this pyramid thing doesn't work because there is no work back. So the way I look at data information knowledge is not as a pyramid, but as a loop. But there's only one half of the data loop that typically works, which is people collect that data, it's translated into some fancy information, everyone pats their back, there are fancy presentations like these. I am not supposed to make presentations. And then people glean knowledge of it and everyone's really happy, but nothing happens. And then you have data, and I'll give you an example of it. That is basically people collecting a lot of customer data. You have like 1 million source systems, you collect all this customer data, somebody spends $500,000, builds a segmentation model, and then everyone sits around for the next 6 months coming up with use cases. All of us have done it. There's no shame in accepting it. And then nothing happens. And then the segmentation lives and lives there. So that's one half of the data cycle, right? So data becomes information, becomes knowledge, but then it just dies a premature death. It just goes in that loop and everyone looks at it and feels bad for the $500,000. So what does a full data cycle look like, according to us, is the data becomes information, information becomes knowledge, and that knowledge has to be translated into action. And if you look at it, it's not shaped in the form of infinity because that's a nice curve. It's because that's how it is, right? That action again gives you more data, and that data helps again get more information and so on and so forth. So let me give you an example of what happens in the real world at the Iconic. So we collect customer data, yes, we build segmentation, yes, we build use cases, but then that use cases just get deployed into actual personalization rather than just being segmentation in a slide, rather than being segmentation in a PowerPoint presentation. It gets translated into actual personalization, and from that personalization or personalized experience, people give us more data, and that data again goes into the information and so on and so forth. So that's how we break the cycle of data becoming just a use case or a good to have, but rather a nice to. Okay, I've lost thought. I shouldn't be talking so fast. I lose my train of thought. Okay, so the two things you should know. The reason the font looks like this and the slide looks like this is typically I do a 3 o'clock, 3:30 session. Everyone's sleepy. Everyone's waiting to go home. So this keeps everyone awake. And the reason I talk fast is because people will otherwise sleep. So they've kindly given 4-5 chairs for me in case I fall asleep. So I'm going to sit there. Okay, so how do we stop thinking and start using data? I have 23 minutes, not bad. So we have a simple framework, and I've been in consulting for a long time, so I like frameworks. You might not like frameworks, so it's easy. So what we do is we do a data set, skill set, mindset approach. I'm sure there are different ways to look at it. I'll talk about what data set, skill set, and mindset is, and from the context of the Iconic, and how we've applied it and how it's worked for us. So when I say data set, I mean tech. The tech side of things, not necessarily data set. Doesn't have to be a SaaS data set or an R data set or a Python. It's a data set meaning tech. Skill set meaning people. I don't mean skill set as in skill set meaning people as a whole, not just the skill set needed to work with data. And mindset is obviously the culture. The reason I have not called it tech, people, and culture is because it does not rhyme. And one thing I've realized is if it does not rhyme, people won't remember it. Now I'm sure you'll remember data, skill set, mindset. Data set, skill set, mindset, and not tech, people, and culture. And that's how we're going to look at that problem and how we've solved it. So the first problem and the base of the problem is data set, right? More often than not, the reason I call it the villain number one, analysis paralysis. More often than not, data is the biggest villain. I don't mean my team. I just mean data as in data, the technology, the tool, the databases. You're either overwhelmed with data, there is so much data, what do we do with this? And then people come and sell this fancy stuff and you don't know what to do with it. Or you don't have what you actually need and you collect all the other useless data and now what do I do with it? So it's either ways data is not useful, data is not actionable. How do we break that loop first is what we'll talk about. The next one is the skill set. When you have this data, when you have these tools, when you have this technology, there's still the problem of the skill set. The skill set problem is one where you don't know how to use this data. Now you have the data, it's all cleaned up, it's all ready to go. I'm sure all of you face these places where you go to this guy, let's say a DBA or a BI guy or a data science guy, and you ask him or her, like, what is the answer to the solution? Or how do we solve this problem? They're like, this already been solved 6 months ago. Why don't you go look at it? And you say, I don't know. I thought this was not done before. And that visibility and accessibility is not there because these things are already done by someone else and it lives somewhere else. Nobody knows where it is. And you do the same problem again and again and again. People change. You repeat these processes again and again. How do you break that cycle? How do you break that skill set or people cycle? And the third one is the mindset. The mindset problem is more often than not, oh, this is all the dark arts, and more often than not, people sell this, and at the cost of making myself look not that valuable, which is what I like to think, is more often, this is a really simple logical thing to do. Anybody with common sense and logic can do data science, right? And the idea is people oversell it, overhype it, there are terminologies thrown in, people start talking about convoluted neural networks and convolute everything, and so they confuse people. So how do you break that myth and how do you get everyone on the data journey is what you talk about. Now, typically people start the journey from the mindset. They're like, how do I change the culture? Then how do I change the skill set? And then how do I get data? We did the other way around. We said, first, let's show credibility by building something with the data. Let's get everyone using it. And the mindset will automatically change, the culture will automatically change. Sometimes people try to change the culture, get everyone on whatever group yoga sessions trying to do data. I don't know what you do, but sometimes people do different things. We didn't do group yoga, but something else. Okay, so how do you not do that is what we'll talk about. And one thing I want to go before I go into the slides is not everything that counts can be counted, and not everything that can be counted counts. This seems like palindrome, but what am I saying? Limerick. But what I technically means is people technically think that everything can be solved with data. There's one group of people who are extremists, the data extremists, who are like, I can solve everything with data. And then I've heard people come up to me and say, why don't you solve world hunger then? And then you can't go anywhere, right? And then the other group of people who believe you can't do anything with data. It's all business. I've done this for 25 years. Your data can't do anything here. And so there's the other camp. So instead of being on either side of the camp, how do we come to the moderate camp is what we're going to talk about. So the first one is the data or the tech side of things. Like I said, analysis paralysis. Like this cartoon says, you do the concept test, focus groups, internet panels, store intercepts, blah, blah, blah. Everyone's done all the market research required to launch the product, but people have already gone old and gone to their homes, right? This technically happens. You run a campaign, you run say a media campaign, an advertising campaign, a sale campaign. It takes 6 months to get the results. By the time either the product is gone or the customers have gone or something has happened, right? So how do you make that cycle faster is what we'll talk about. So there are two things we've done, and in all these sections, I'm going to talk about only two things because I don't want to bore you beyond what I'm already boring you with. So the two things that I'm going to talk about is one for the business, and the other one is for the team or my team or the data team, right? So for the business side of things, let's talk about the feature of the metric library. I'll come to that. And the second thing is data as a microservice. So I'll come to both of that in a little bit more detail. So the first one is the feature library. Of course, this is not any way illustrative because I didn't find a better graph, and I did this on my phone, so you have to excuse me. So what do we mean by a distributed feature library is more often than not, okay, this is too boring to look at. More often than not, if you're in the business and typical question is, can you tell me or show me all the customers who've done this, and this, have been through this journey, have done that, and then people throw multiple terms at it. It's called single customer view, it's called single source of data, or single source of truth, or whatever, the Holy Bible, or whatever it is, right? You call all of these fancy terms to describe the single place to get all of this information. What we call it is nothing but a feature library. What I mean by that is at the Iconic, we have a feature library of customers. Every single customer, there are 4.3 million active customer base. So every 4.3 million people can get 865 different features about these customers. What have they bought? What have they seen? How do they buy? What device do they use? When did they come last? How do they shop? Every single thing is available in the denormalized form in one single table for all these customers so that people don't have to know how to write code, how to write programming, or do all this fancy stuff. So anybody who knows how to use a mouse and point and click can go and say, show me this set of people who've done this behavior, and you'll get a list of people and you can do something with it. So what this feature metric library does for us is it helps people continuously enrich information about our customers so that you don't have to keep finding out the same thing again and again and again about your customers. So it not only helps the business, say for example, the marketing team quickly come up with segments or smaller groups or trying to help the product team design better features. What it also does is if you are somebody who's done your machine learning part of it, and if you're somebody who's talked to a data scientist, they typically say 90% of the job is cleaning data and creating features. We take that 90% job away and we create a feature library where everything is automated already, and people can keep adding more and more features through a pull request or whatever it is that they like to do, and there are more features that are built. In this way, people instantly get information about all your customers in one go and what he or she's done without having to spend 16 weeks getting information about 50 people who've done this particular behavior. You get it in 16 seconds. So that's the idea. So what we do is a typical customer feature library. There are 865 odd unique features at a customer level, and it increases continuously. And this is continuously contributed to by the business and also by the teams themselves when they build new features and build new initiatives. The second thing that we do, and like I said, one is for the business and the other one is for the team. For the team, what we do is we follow the microservices architecture, not just in data, but across the whole tech platform. When I mean a microservice, what I mean is, for example, what we're trying to do right now in the past 5-6 months is we've been trying to teach the machine to understand fashion. So if I take a photo of you, it'll split up all the whole outfit, your top, your pants, your accessories, and it'll give you a fashion score based on 1 million other images or 10 million other images the machine has seen online. So what that is doing is trying to figure out a way to assemble or put together a look that you don't have to spend time pairing each other. For example, I don't know if I'm dressed well, so I take a photo of myself and it will say I'm dressed on a scale of 1 to 10 like this based on my fashion preferences and who I am. So these kind of initiatives are really possible only if you give the team the flexibility and the freedom to build this by themselves and without having to integrate with the monolith. So instead of having to integrate with some old database that we have that will never get updated or upgraded forever, what we let people do is you build your own system, your own microservice. That whole fashion as a service is a whole microservice that somebody builds in a separate platform in whatever language they want, however they want, saves data wherever they want, and then that continuously gets updated and improved, and that just talks to the main platform through an API call or something like that. So without having to spend a lot of time trying to build this and integrate this, a lot of time we've seen with data is you waste time integrating stuff. What we let people do is build it separately, build it as a microservice, and that has actually helped us really accelerate what we do. So for example, if you have returns and you want to predict returns, we build it as a separate microservice. If you want to make payments, we build it as a separate microservice. If you want to do personalizing on emails, we build it as a separate microservice. So all of these algorithms, all of these concepts and replenishment algorithms, everything is a separate microservice sitting by itself, has its own code base, it's completely clean, and that helps people not having to waste time and fight it out on what code base is the best, what language is the best, and all that stuff. They just build it in their own way. So for example, like I said, in this example, instead of having personalization force-fitted into our existing systems, what we do is we let it be a microservice, and people can build whatever they want, whenever they want. So how do you measure the success of breaking down this disparity? The only way that we measure it is we stop talking about databases. We stop talking about putting things in databases and spending time cleaning up the partition key and vacuuming it and sweeping it and mopping it and all of the stuff that you typically do. Everything is a data source. Like I said, the exercise that we're talking about where we trying to teach the computer to understand fashion, it needs 10 million images, and you are not going to put 10 million images in a RDBMS or in a PostgreSQL. So these kind of things need to start coming up with newer data sources. So we put everything in an amorphous data source, and the more and more we start putting our databases into data sources, into centralized data libraries or feature libraries, is how we measure the success of our initiative with breaking down data disparity. The next one I'm going to talk about is skill set or the people. So the typical skill set problem with reality is this, right? For example, this cartoon says, for those of you who can't read it, our ideal candidate would have a skill set that applies to at least 3 areas that don't exist yet. This is typically how we hire. We hire people, and then 6 months down the line, everything changes. Everybody in marketing is expected to do data. Everybody in everywhere else is expected to do data. So how do you break that barrier, and how do you overcome this skill set roadblock is what we'll talk about. So we do 2 things, one for the business and one for the team. Everything is 2 things, one for the business, one for the team. The business part is single unified reporting, and the team part is the Federal Data Republic. It sounds very fancy, but I'll make it very clear. So the single unified reporting platform, or SURE for short, is named so because every time somebody came to us and said, do you want to build a report for this? We'll be like, sure, we'll build this. Do you want to build this? Sure. And everyone kept saying sure, so like we just said, well, let's say, name this platform SURE. So what the SURE does, or single unified reporting entity does, is all the reporting across the business, any reporting, it could be dashboards, it could be operational reporting, performance reporting, predictive model outputs, everything lives in one entity, one platform. So we built our own in-house platform called Apache Superset. It's an open source application. It's a visualization platform that lets you integrate with multiple data sources, come up with your own visualizations, and we build that, and it integrates with all the data sources and all the data features and all the metric libraries. What this helps people do is, for example, if I put this SURE or the single platform in front of a feature library, somebody who has no idea what code is, what data is, can just go to that data platform and say, okay, now I'll create a rule list saying people who have done this, and this. Give me a list of people, it'll just give you a downloadable list. So you don't have to know programming, you don't have to know your databases, you don't have to know anything else. And the same way, if somebody has to track operational performance versus the overall company performance versus marketing performance, they can see everything in one platform. What this does is breaks those silos where different platforms have different reports in different places, and you waste half your lifetime just getting access and license and all of this stuff. So we break that barrier down through this SURE platform. So we have all our customers in one platform. And the other thing that we do for the wider team and not for the business is the Federal Data Republic. So what we mean by that is there's this famous concept in the microservices architecture called polyglot persistence. If I put that, more than half the people fall to sleep, so I just change it to Federal Data Republic. So what polyglot persistence or Federal Data Republic means is letting people build whatever they want, however they want, as long as it adheres to practices. So what I mean by that is, we don't force people to only use Postgres database. For example, there is this belief, if you're in the tech team, you force people to use only one particular architecture, or use only one particular language. People only hire Python talent, people hire only R talent, or Scala talent, or whatever talent you want to hire, or Pascal, for those of you who are interested. And instead of hiring those isolated silos, what we do is we hire people for what they can do and how they think. And then, like I said, through the microservices concept, people can build in whatever language they want, in whatever platform they want, as long as all of that follows, all of it is tracked by code climate, all of it is tracked by code coverage and all of those best practices, so that we make sure that it's built according to the best standards, but people are not forced to follow a particular technique or a tool or a language. And what we've seen with this is, the more we let people do whatever they want, the more they converge to one particular language, instead of forcing people to have converged to one language. So I've been in different companies where, if you are not a Python person or an R person, for those of you who know in this room, you were looked down differently. It was almost like a caste system. I'm from India, and so it's like a caste system. You knew Python, you didn't know R, so they would look down upon you and all of that stuff. So we don't do that. You can do in whatever language, you can build in whatever language you want. You can maintain in whatever language you want, as long as it's built in the best practice and best possible way. And similarly with the data sources, like I said, there is no such practice as it should be a relational data source or a graph data source or whatever it is that you want, or a key value store. People can build in whatever format, whatever shape they want, as long as it adheres to common standards. And that's what that has done is, for example, it has helped build what we call the La La Land. So we have something called La La Land, not because it sounds funny, but because it's the acronym for listen always and learn always. So if you take the concept of the Federal Data Republic and the microservices, a good example is a La La Land, where you can build a microservice or a nano service, where you just tell it, these are all the features. Like I said, you have a feature library. These are all the inputs. This is the value I want to maximize. So if you want to maximize, let's say, profit, second line profit, if you want to maximize email open rates, throw all the features at it, throw the target variable at it, build a microservice. It will keep building that model continuously, and it will keep spitting out an output every week, every month, and you don't have to invest an analyst who has to go look at it every time a campaign runs. It keeps learning, it keeps listening, and then it keeps sending you an output when there's a significant deviation from a standard set of coefficients. So something as simple as that, running by itself on a microservice in a different platform. So I build typically in R, my team builds in Python. So they build whatever they want, they deploy it, it's scheduled, it's an airflow somewhere, and then people can keep continuously listening and learning, instead of every time having to redo this over and over and over again. So what happens is somebody asked a question a year and a half ago, the answer for that will still keep coming a year and a half later, not that somebody has to ask that question again after 1.5 years and you spend another 3 months doing that problem. So once you solve a problem, it's solved forever, and it's listening and learning always. So that's something we do, and that's only made possible because of a feature library, because of our microservices, and because of our approach to Federal Data Republic. So yeah, build in R, build in Python, build in Scala, build in Pascal, build in C++, whatever you want. So how do you measure the success of the skill disparity, of bridging this skill disparity? Is one, like you've seen, we don't call them dashboards. At the Iconic, we call them dash tools. So we're starting to call them the dash tools. What I mean by that is, these are not just boards where it gives you information. Because we built this dashboard, say a platform in-house, what it also has are action buttons. So if you, for example, are a planning manager and trying to replenish a product, what you can see is, you can see exactly how many units need to be replenished. You just click a button and a purchase order gets made for that particular amount of replenishment. So what we are trying to build is, we're trying to integrate dashboards and predictive models and also a tool all in one place, so people don't have to go across multiple platforms and do them. So that's one thing we do. And the second thing is, there's typically this culture of don't play with the data choices. You don't get to make the platform choices. You don't get to make the tool choices. We don't do that. We celebrate failure as much as we celebrate success. So for example, this is common story that one of the data scientists joined the business. He wrote a catalog sorting algorithm. And the moment he wrote this, that was his first week in the business, he wrote the catalog sorting algorithm. For those of you who don't know what a catalog sorting algorithm is, if you go onto the page, you see a list of products on the catalog. It gets sorted based on an algorithm, based on who you are and what you do. So he built a catalog sorting algorithm, and then we sit down and watch it, and we track it real time, and the performance compared to the general algorithm is going poorer and poorer and poorer, and went like 4% negative compared to a baseline performance. Instead of having a commission and worrying about why it happened, everyone celebrated and said, finally we built something that's different from what's happening. And so that is the kind of culture we want to be in, where everyone feels psychologically safe to say, let's make this mistake, at least we know it doesn't work, and then try to do something. And we keep iterating, repeating, and repeating. And now we have a sorting algorithm, which actually does 12% better than what we had a couple of years back. So we can only get there only if we can fail fast and fail quickly. That will only happen if you give people the flexibility in terms of a microservices-based application and a federal data republic. The last one is mindset. I'm sure I'll quickly finish it. So for example, there's a lot of lack of trust and with the data and insights. It's necessarily not because of the team or the data, it's just a function of a lot of things put together. So this Dilbert comic says, I didn't have any accurate numbers, so I just made this one up, whatever, $4 million, right? Studies have shown that accurate numbers aren't that many useful once you make them up. How many studies? 28. So this is what happens, right? People just make numbers up, and some people just take that blindly, and once that trust is broken, you don't trust any number given by anyone in the business. So how do you bring that credibility back up? How do you show people that what we are saying is actually worth the salt, and how we actually do these things? Oh, I talk a lot. Okay, so how do you do that? We do it through two things. One is our data governance strategy, and the other one is inner sourcing and inner recruiting. I didn't get a better buzzword, so I'm just going to call it that. What is a data governance strategy? Honestly, I didn't want to bore you at beyond 3:45 p.m. with data governance. So I'll just suffice to say data governance for us is three parts. One is accessibility, the other one is privacy, and the third one is integrity, API. So accessibility, meaning everybody in this business has access to all the data in the right form, in the right shape, in the right tool, in the right platform. That is a single unified reporting entity that we have. So we came up with a data governance strategy, which was literally, when I mean literally, I don't mean figuratively. I know the difference, thankfully. I've learned it recently. So literally signed off on a data governance strategy. The execs across the business signed off on it, which had three components. One was accessibility, which is the first part I talked about. Everybody in the business, almost 700 people in the business have access to all the tools and all the reports. Right now, if I open up a dashboard, you can see around at least 300 people using those dashboards and making decisions. So everybody in the business has access to it. That is the accessibility. That is the first part we try to solve. The next part is privacy. Obviously, because we open up it everyone, we need to be doubly, triply sure that everyone has right access, right controls, right tools. So we work on that part of things. And the last one is the integrity. Because you come up with more metrics, what ends up happening is people start asking, how do I trust this number? I don't trust this number. So there's always this bigger debate or school of thought on reducing the number of metrics or increasing the number of metrics. Reducing the number of metrics argue that if you give people more metrics, people are going to get more and more confused. And increasing the number of metrics, school of thought argues that if you don't give more metrics, we can't make better decisions. So what we've resorted to is we come up with a predicted confidence score on all of these metrics. So when someone uses a metric, it says, I'm 100% confident this metric is right. If somebody uses a different metric at a much lower granularity, it says it's 70% right, so you can make a better decision with it. So that's something we did as part of the data governance strategy. And the final one is the inner sourcing and inner recruiting. It's just too many things. Okay, so what I think about it is I like to think about the whole data. Like I said, if I had to explain it to my grandmother, I'd explain it as somebody helping data into decisions. So I like to think of data as oil, data engineering as the pipes that are put into the ground to extract the oil. And then data science is that process, wherever you convert that oil into petroleum. And then decision science is where you try to sell that petroleum to people to say, if you don't use petrol, you can't run your cars. And then decisions is people buying that petroleum to run cars, right? So you need to do this whole process before data can get to decisions. And instead of hiring multiple people, instead of hiring data engineers, data scientists, machine learning engineers, machine learning platform engineers, machine learning platform data science engineers, machine learning platform data science database, you have so many titles, right? So instead of hiring all of that, what we try to do is we try to inner source it. And when I mean inner source, what I mean is a lot of data is generated in the business by the tech team that builds these platforms. If you're a tech team, you build a new app, you build a new website, you build a new feature. Instead of building multiple data, instead of hiring more database engineers to get all of this data, what we've done is we've built a message queue-based application where the people who build this data or the platforms can automatically stream the data into the database, and we don't have to do any data engineering. So we've actually built that, and all the microservices in this business directly stream data into a platform. It goes into a sink, and anybody can use it. Similarly, with the decision science part of things, more often than not, when I mean decision science, all I mean is report building and dashboarding. People ask the same question again and again and again, and they are going to ask it again and again and again because they don't get the answers as soon as they want. What if we build this dashboarding platform where anybody can go and get all this information anytime they want, can simulate whatever they want, can play with it and put in whatever value they want and get all of that stuff? You save a lot of time, and again, you're inner sourcing by pushing it to the people who make the decision. So that's inner sourcing. I probably won't go into too much detail because I have exactly 53 seconds. And the next one is inner recruiting. So what we technically do is we rolled up all of these three features of data science, data engineering, and decision science into one role. We call them the full stack data scientist or a T-shaped skill. And what we also do is, because different areas in the business have different skills, for example, the software engineers in the business and the full stack developers in the business already have the DevOps and a bit of the data science part of things. So we hired them and we trained them on other parts of the business, so that instead of hiring a new data scientist every time, instead of hiring a new DevOps every time, we just find people within the business who want to move to this new role and try to do these things. So that's the other thing we do. We'll probably go into this more detail. So our team's motto is Avia Pervia. I saw this somewhere recently. Avia Pervia is making complicated look simple. That's the motto of the team. We don't try to sell jargon. We don't try to say this is really complicated. We try to make it really, really simple. Like in Ratatouille, the motto is anyone can cook. Our motto is anyone can data science. So how do you measure this? Instead of having one data team for the company, our motto is the whole company is a data team. That's the only way you can measure that the mindset has changed. That's the only way we know that we've changed what we do. And for those of you who find a lot of struggle with all this data as two concept, at the end of the day, what's the big deal? It's a 50-50 thing that will work. I have a 50-50-90 rule. Anytime somebody says it's a 50-50 thing, it will work, 90% of the time they'll be wrong. So you can use that axiom and you can use it on them. So that's it from me. Thank you very much for listening and not falling asleep.